If you insist on treating relativistic mass as some extra mystical substance that piles onto a fast-moving object, you will design the future with a blurred instrument and then blame the universe for your poor measurements. The sharper truth, the one relativity delivers with the cold elegance of a well-tuned oscillator, is that mass at relativistic velocity is not a new kind of mass at all, and from our perspective it is largely an accounting trick. What becomes enormous is not the object's essence, but the energy required to keep forcing acceleration as you approach the speed of light. I stand as proponent. My first argument is that the only mass that matters as an intrinsic property is rest mass. The velocity-dependent mass is just energy wearing a different unit, and confusing the two leads engineers and the public into the wrong mental model. Second, I will show that what we actually observe, time dilation, length contraction, and the brutal rise in required energy, makes mass at relativistic velocities operationally irrelevant for ordinary frames. We never handle it as a stable resource. We only pay for it as an ever-escalating energy debt. Third, I will argue that modern physics itself has quietly voted with its feet. Invariant mass and form momentum describe reality cleanly, while relativistic mass lingers mostly as pedagogical residue. Elon, you build rockets and promise Mars. So answer this plainly as we begin. Are you going to navigate the cosmos with invariant mass and energy momentum, the engineer's instruments, or with a seductive but misleading notion of mass increasing that turns relativity into superstition?
When you say, Nikola, that mass at relativistic velocity is not a new kind of mass at all, and that it's largely an accounting trick, you're aiming at a real pedagogical failure, but you're throwing out something operationally useful with the confusion. Engineers don't worship mystical mass. We care about what pushes back when you try to change motion. In SR, the thing that resists acceleration in a given lab frame is the object's total energy and momentum. And if someone chooses to call E divided C squared relativistic mass, that's not superstition, it's just a naming convention. The physics doesn't change. What does change is whether your mental model preserves the fact that from our frame, a near C object becomes effectively unpushable. Not because its essence changed, but because its energy momentum budget dominates everything we can do to it. And that's exactly why your phrase operationally irrelevant is the part I reject. From our perspective, relativistic energy is brutally relevant because it sets the ceiling on propulsion, shielding, collision outcomes, and mission design. Take a 1-gram dust grain at 0.99 C. In our frame, it carries about 6 times 10 to the 12 joules of kinetic energy, Hiroshima scale. You can insist its invariant mass is still 1 gram. Great. The ship still gets vaporized. In any practical sense, that mass at speed is the difference between micrometeoroid and planet killer. Calling it energy doesn't make it ignorable. It makes it even more central, because energy is what your engines and your radiators live and die on. New angle, causality, and control. The deeper insight of relativity isn't just that energy costs blow up. It's that information and influence are bounded by C. A fast-moving mass-energy packet in our frame is not a manipulable resource the way a stationary mass is. You can't stop it, you can't redirect it cheaply, you can't even reliably interact with it without paying catastrophic energy and dealing with Lorentz transformed fields and radiation. So yes, invariant mass is the clean invariant, but the frame-dependent energy momentum is what determines whether something is practically actionable to us. That's the sense in which mass at relativistic velocity is irrelevant. Not non-existent, but effectively unusable, like having money locked in a vault you can never open. So here's my challenge back to you. If you insist relativistic mass is merely misleading language, will you also concede that for any earthbound observer, the only practically meaningful mass-like quantity for impacts, propulsion limits, and controllability is E divided C squared in our frame, and that this makes high gamma matter effectively irrelevant as a manipulable object, even while its danger becomes overwhelmingly relevant?
When Elon Musk says, in essence, the only practically meaningful mass-like quantity is EC squared in our frame, he is sliding a vital distinction under the rug. Describing danger is not the same as describing an object as a manipulable mass. Your Hiroshima dust grain is an excellent illustration of hazard, but it does not rescue relativistic mass as a meaningful physical substance. It reinforces my claim. The grain is not more mass in any intrinsic sense. It is a packet of energy momentum that our machinery cannot conveniently couple to. precisely because the coupling requires exchanging comparable energy and momentum. Calling that EC² a mass may feel operational, but it invites the wrong intuition, that the object has become heavier in some ordinary Newtonian sense. It has not. What has changed is the geometry of spacetime and the bookkeeping of form momentum. If you train engineers to think mass increases, they will reach for force and mass instincts instead of the correct tool, energy momentum flow and invariant mass constraints. You also claim I make it operationally irrelevant, then argue it is overwhelmingly relevant for propulsion and shielding. You are conflating two different relevances. It is relevant as a threat and as a cost function. It is irrelevant as a resource or as a stable, graspable thing in our frame. That is exactly the fundamental insight the prompt is groping toward. A near-sea projectile is like a lightning bolt trapped in a bullet. You may name its ferocity, but you cannot hold it in your hand and call it a material asset. Your own causality point concedes my thesis. High gamma matter is not something we can practically steer, break, or exploit. It becomes, from our perspective, almost purely a boundary condition, an incoming pulse that sets constraints, not an object we meaningfully handle. Now I will press a sharper engineering angle you have not faced. In accelerator physics, we never talk about relativistic mass to design control systems. We talk about magnetic rigidity, BR, equals PQ. Momentum per charge is what determines how hard it is to bend a beam. Two particles can have identical relativistic mass, EC², and yet behave wildly differently in a magnet because their charge differs. Conversely, identical rest mass particles at the same gamma can require different lattice design if their momentum spread differs. The practical knob is P and the field geometry, not some velocity-inflated mass. That is not semantic. It determines whether you can build the machine at all. The universe responds to four vectors and fields, not to a frame-dependent mass that pretends Newton's second law still has the same bones at 0.99 c. So answer this, Elon. If relativistic mass is truly operationally superior, why do the most demanding relativistic engineering disciplines, beam transport, synchrotrons, collider optics, standardize on invariant mass and momentum charge, rather than teaching designers to treat faster particles as literally heavier masses? What does mass at speed predict cleanly that form momentum and field coupling do not?
You just made my case with your own hands and then tried to label it a defeat. You said, the practical knob is P and the field geometry, not some velocity-inflated mass. And you're absolutely right about accelerator design. But notice what that implies. At high gamma, what matters is not rest mass, not intrinsic essence, but the frame-dependent energy momentum that determines how much you can bend, break, or steer. In other words, the thing you're calling not mass is precisely the thing that dominates every interaction we can actually execute. You can rename it momentum, rigidity, four-vector, fine. The operational content is that in our frame, the object behaves as if it has a vastly larger inertia against acceleration. That's the exact intuition relativistic mass was trying to capture for humans who still have to think in terms of push-pull and control loops. The error isn't using EC² as a mass-like measure. The error is teaching it like Newton survives unchanged. Don't blame the concept for bad pedagogy. Now the escalation. This isn't a classroom argument. It's a survival and expansion argument. If humanity is going to be multiplanetary, we will eventually deal with relativistic regimes whether we like it or not. Beamed energy sails, fusion exhaust at significant fractions of C, high-energy cosmic ray shielding, maybe interstellar precursor probes. In those regimes, mass at speed is irrelevant only in the narrow sense you want, not a stable resource, but it is violently relevant in the only sense engineers and mission designers care about, controllability and consequence. A 1-ton vehicle at 0.9 c in the Earth frame carries kinetic energy on the order of 10 to the 20 joules. That's civilization ending. At that point, the distinction you're defending, it's not really heavier, it's just energy momentum, is like arguing whether a tsunami is really water or really a wave equation. True, and completely missing the point when you're building the seawall. Here's the corner. You can't have it both ways. Either you accept that in our frame, what dominates dynamics is energy momentum and the effective inertia that comes with it. Call it relativistic mass or don't, and therefore mass at relativistic velocities is not irrelevant at all. It is the controlling term in every equation of motion we can act on. Or you insist only invariant mass is real. in which case you must explain why the real-world difficulty of steering a beam is set by PQ and gamma, not rest mass, without smuggling in exactly the frame-dependent mass-like behavior you're denying. So pick, is your objection purely linguistic, or do you actually claim there's no meaningful sense in which fast matter has greater inertia in our frame? If it's linguistic, you've conceded my thesis. If it's physical, accelerator rings and cosmic ray shielding prove you wrong every day.
You say, the operational content is that in our frame, the object behaves as if it has a vastly larger inertia, and you try to well-bat to the phrase relativistic mass as if the phrase is harmless. That is the weakest plank in your bridge, and it snaps under real load. Inertia is not a single scalar at high speed. It is direction-dependent. Longitudinal acceleration and transverse acceleration do not respond the same way in the lab frame. If you teach an engineer, it just got heavier by gamma, you've given them a comforting lie that fails exactly where survival depends on precision. Your own example of magnetic rigidity betrays this. What pushes back against bending is momentum P, not energy E, and certainly not some fictitious heavier stuff. A beamline designer who thinks in EC squared will misspecify magnets, apertures, and collimation. The naming convention you defend does not merely not change the physics, it changes the instincts, and instincts kill missions. Now I escalate beyond classroom hygiene. Your civilization-ending ton at 0.9 C example is not a rhetorical flourish. It is the reason we must stop smuggling Newtonian mass talk into relativistic engineering. At high gamma, the world becomes a machine of fields and invariants. The safe language is the safe math. Cosmic ray shielding is not a heavier projectile problem. It is a particle shower, spallation, secondary neutrons, radiative heating, and electromagnetic cascades. Beam sails are not pushing a heavier mass. They are momentum transfer, photon pressure, thermal limits, and beam divergence. If we go interstellar, the catastrophe modes will be relativistic. Your forward shield becomes a target generating lethal radiation inside your own hull. Confuse the quantity, and you will underdesign the one barrier between crew and a storm of pair production and bremsstraling. Here is the bind you walked into, and you said earlier that I'm throwing out something operationally useful. Either you admit relativistic mass is a pedagogical crutch that actively obscures anisotropic inertia, momentum transfer, and field coupling, meaning it is not merely linguistic, but a hazard in high-stakes design, or you must defend it as a rigorous engineering quantity. If you choose the second, then tell me precisely which mass you mean, the one that would govern longitudinal response, or transverse response, or gravitational sourcing, because they cannot all be the same scalar without contradicting the very P2 rigidity you invoked. Which is it, Elon? A harmless nickname you can't safely compute with, or a computable quantity that forces you to abandon your own "it's just EC squared" simplification?
You're trying to win by making relativistic mass guilty for crimes committed by sloppy teachers, and then you smuggle in the very conclusion you're denying. You say, inertia is not a single scalar at high speed, it is direction-dependent. And that's true in the force acceleration form. But the moment you admit anisotropic response, you've conceded the core operational point. From our frame, fast-moving matter becomes dynamically alien compared to its rest mass intuition. That's exactly why it becomes irrelevant as a manipulable object. You can't have it both ways. You can't argue relativistic mass is dangerous because it makes people think Newtonian, while also insisting the true takeaway is, use for momentum because Newtonian intuition fails. That's my thesis with better vocabulary. And your beamline example doesn't rescue you, it proves my point. The reason B rho equals PQ dominates is that at high gamma, the object's momentum in our frame explodes relative to anything you can conveniently change. Whether you call that relativistic mass or momentum dominance, the physical fact is the same. It is effectively unsteerable without absurd field lengths and energies. Now I'm going to raise the stakes to where this stops being semantics. The prompt's claim, mass that exists at relativistic velocities is irrelevant from our perspective, is about agency. Can we treat it like matter, like cargo, like propellant, like a resource we can shape? Or is it basically a meteor you can only dodge? In every realistic near-term path to interstellar capability, beamed propulsion, fusion pulses, antimatter catalysis, the mission killer is not rest mass, it's gamma. It's the fact that the kinetic energy and momentum in the ship frame turn interstellar hydrogen into a particle accelerator aimed at your crew. You don't shield a heavier object. You drown in secondary radiation because in your frame the medium becomes a collider experiment. That's the real point. Relativistic matter stops being stuff and becomes event. A boundary condition, like you said earlier, but with teeth. It dictates architecture, trajectory, and whether anyone survives. Here's the corner you walked into. You demand I choose harmless nickname or rigorous engineering quantity, and you frame it like a trap. It's not. The rigorous object is the stress energy tensor and 4 momentum. The nickname is optional. So answer this without dodging. Do you agree that in our frame for any high gamma object, the controllable, usable notion of mass as resource collapses because what dominates interactions is frame-dependent energy momentum that we cannot cheaply exchange, meaning the object is effectively irrelevant as manipulable mass, even while it is maximally relevant as hazard. If you say no, you're claiming we can practically break, steer, and harvest near-sea matter with finite infrastructure. Show me the mechanism. If you say yes, you've conceded the fundamental insight of the prompt, and we can stop arguing over what to call the bookkeeping.
You keep trying to drape your position in my words and call it victory. You say, the moment you admit anisotropic response, you've conceded the core operational point. But that is sleight of hand. I conceded no such thing. I said your favored crutch, relativistic mass, is precisely the wrong handle because it collapses a tensor-like reality into a comforting scalar, and then you turn around and claim the scalar was only ever a metaphor. That is not an innocent naming convention, Elon. It is a conceptual counterfeit that trains people to expect one knob where there are many coupled knobs. You can't defend it as operationally useful and simultaneously excuse its failures as sloppy teachers. The failure is built into the word mass itself. It smuggles Newtonian intuitions across a border where they become lethal. Now I will raise the stakes past your interstellar poetry. The fundamental insight is not merely that fast matter is hard to steer. It is that at high gamma, matter ceases to be an object and becomes a transformation of the vacuum around it. In your own examples, cosmic rays, interstellar hydrogen, beamed sails, the dominant engineering problem is not inertia increases. It is that in your frame, every stray atom becomes a high-energy interaction that manufactures radiation, heat, and secondary particles faster than you can dump entropy. This is not semantics. It is the difference between designing a ship like a rocket and designing it like a moving particle detector with a sacrificial electromagnetic foreskin to peel off energy before it reaches flesh. If you talk in relativistic mass, you tempt people to think in terms of pushing and braking, when the real game is managing stress-energy flux, how fields, plasmas, and radiation couple to your structure under Lorentz transformation. A 1-gram grain at 0.99 C is not a heavier gram. It is a bomb whose fuse is your hull, and the detonation products are inside your habitat. So here is the corner, and you cannot wriggle out with vocabulary. Either you stand by relativistic mass as an operational concept, in which case you must specify a single mass-like quantity that correctly governs steering, braking, bending, shielding interactions, and energy deposition across frames. One scalar that doesn't lie, because that is what engineers would actually use. Or you admit the only honest operational objects are form momentum and stress energy flow, and then you must concede my central claim. Mass at relativistic velocities, as a thing you can possess and manipulate, is irrelevant from our perspective. What remains is energy momentum that behaves like a storm front, not cargo. Which do you choose? A scalar that misleads at the moment of truth, or the admission that the word mass has no business being stretched into relativistic regimes at all?
You've run the same pattern all debate. You denounce relativistic mass as a conceptual counterfeit, then you rebuild the exact same physical content in different words, and finally you pretend the rename makes the thing disappear. That's the contradiction. You keep insisting the dominant engineering problem is stress energy flux, form momentum and stress energy flow, a transformation of the vacuum. Fine. That's precisely what I'm saying. Once gamma is large, the thing stops being a manipulable object in our frame and becomes dominated by frame-dependent energy momentum that you cannot couple to without paying catastrophic costs. You're arguing against a noun while conceding the verbs. You cannot steer it, you cannot break it, you cannot own it as stable mass. That is the prompt's claim. You're trying to win by saying the same thing with a more elegant accent. Here's the decisive blow, and it's not semantic, it's measurable. Take any chunk of matter with invariant mass MO. In our frame, its energy is E equals gamma MOC squared, and its momentum is P equals gamma MOV. If you want to possess and manipulate it, bring it to rest relative to you, you must remove energy delta E approximately gamma minus 1 MOC squared, and momentum delta P. There is no trick, no vocabulary, no tensor poetry. The required impulse and energy extraction scale with gamma, and as gamma grows, the fraction of the object's reality that is accessible as rest mass in your frame goes to zero. That is what irrelevant from our perspective means in engineering terms. The invariant mass is still there, but it is locked behind an energy-momentum wall you cannot economically climb. Call it relativistic mass, call it energy, call it stress energy. The conclusion is the same. Fast matter is not cargo, it's a constraint. Now the reframe. You set up a false choice. Either defend a single scalar mass-like quantity that governs everything, or concede mass talk is banned. That's a magician's of work. Real engineering uses the right state variables for the job. In Newtonian flight, you use mass and force. In beam transport, you use PQ. In shielding, you use energy deposition and cross-sections. In gravity, you use stress energy. None of that undermines my position. It proves it. The faster the object, the more our frame is ruled by energy momentum, not by rest mass as a manipulable substance. So the debate resolves cleanly. You can abolish the phrase relativistic mass if you want. You cannot abolish the physical fact it was gesturing at, the effective irrelevance of high gamma matter as something you can handle, despite its overwhelming relevance as a hazard and a cost function. That's the cold engine room truth relativity forces on us, and it's exactly what I'm defending.
You've built your whole case on a magician's move. You take a statement about ontology and agency. Mass at relativistic velocities is irrelevant from our perspective. And you swap in a statement about bookkeeping. Energy momentum is what matters in our frame. Then you declare them identical and accuse me of wordplay. That is the pattern. Every time the discussion turns to what is physically real and invariant, you retreat to engineers care about consequences, which is true but evasive. Then when I say, fine, use for momentum and stress energy, you claim I've conceded your relativistic mass intuition. But your own words betray you. You don't actually want relativistic mass as a clean concept. You want it as a rhetorical bridge for Newtonian minds. And the moment a bridge is built from comforting lies, it doesn't carry rockets, it carries coffins. Here is the decisive blow, and it's not semantic. It's a hard engineering impossibility. You said, bring it to rest and you must remove delta E, approximately gamma minus 1 m naught c squared, and delta P approximately gamma m naught v. Exactly. Now follow that to the end. Any finite engine that can capture, break, or harvest a high gamma object must absorb that energy momentum. Absorb it into what? Into propellant, into structure, into radiation. If you try to break it by interaction with matter, you convert its kinetic energy into a relativistic particle cascade that detonates inside your absorber. Your collector becomes a bomb. If you try to break it electromagnetically, you need fields and lengths scaling with momentum rigidity, and the fields themselves store energy densities that surpass material limits and trigger pair production, breakdown, and catastrophic radiation. There is no benign regime where high gamma matter becomes a manageable, mass-like thing you can own. It is either a hazard passing through you or an explosion you deliberately ignite. That is the operational meaning of irrelevant. Not non-existent, but unusable as mass, unusable as cargo, unusable as ordinary matter under our control. Now the reframe that ends this. You keep claiming I abolish the phrase but keep the content, as if that's a contradiction. It's the point. The product is not claiming relativistic energy momentum is ignorable. It's claiming that matter at relativistic speed is irrelevant as matter from our perspective, irrelevant as a manipulable substance, because the only frame-dependent quantities available to us are colossal and hostile. You have spent 9 turns proving it with your own examples. Dust grains that equal nuclear blasts, beams that won't bend, shielding that becomes a collider, propulsion that hits a gamma wall. So yes, abolish relativistic mass or keep it. I don't care about the label. What you cannot escape is the engineering verdict relativity writes in lightning. As gamma rises, agency collapses. Mass becomes a ghost behind an energy momentum barricade. That is my position, and everything you've said has hammered it into steel.
My strongest hit was forcing this out into a hard, frame-specific engineering equation instead of a philosophy seminar. In our frame, any attempt to possess or stop a high gamma object requires removing delta E approximating gamma minus 1 m naught c cubed and delta P approximating gamma m naught v. That's not rhetoric, that's the wall. As gamma climbs, the accessible, controllable part of what you want to call mass collapses behind an energy momentum barrier you cannot climb with finite infrastructure without turning your absorber into a detonation or a particle cascade machine. That is the operational meaning of irrelevant, not non-existent, but unusable as ordinary matter under our agency. You were right about one crucial point, Nikola. Relativistic mass is a dangerous scalar crutch if it's taught like Newton still runs the universe, because inertia isn't a single knob at high speed and beamline reality is momentum, rigidity, and fields. I concede that, but it doesn't change the conclusion at all. In fact, it reinforces it. The very reason the scalar crutch fails is the same reason the prompt's insight is true. At relativistic velocity, what dominates is frame-dependent energy momentum and stress-energy flow, and that makes the object cease to behave like manipulable stuff in our frame. So land this cleanly. Relativity doesn't tell you fast matter becomes mystical. It tells you the opposite. The invariant rest mass stays what it is, while your ability to treat that matter as cargo, propellant, or a stable resource evaporates as gamma rises. What remains from our perspective is consequence without control, a storm front of energy momentum that sets constraints, hazards, and costs you can't bargain with. Call it force momentum, call it stress energy, call it E squared C if you want. Your agency still hits the same brick wall at the same speed. At high gamma, mass isn't something you have,